Hello and welcome to section 8.2, video number 3. This is the third of 4 videos. And in this section we'll continue looking at our polar graphs, and specifically we are now going to be looking at the graphs of roses. So let's say we have the following equation. Let's say we want to sketch r is equal to cosine of 2 theta. If we were to draw our cosine graph and make the appropriate transformations, the 2 in front of this means what? Well, this is our k, so it's 2 pi over k, 2 pi over 2, which means that our period is now shrunk down to pi. So if I draw this graph, and I'm actually going to draw 2 periods, because I want to get all the way to 2 pi. That's one time around the unit circle. So when I start plotting the points of this sketch, I have the appropriate locations. So if I go 1 minus 1, our amplitude hasn't changed. But now, what happens is, instead of making a complete cycle in the distance of 2 pi, it's now made the complete cycle in pi. So it makes another one by the time I get to 2 pi. So these values here are pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So the reason I draw those points is I want to know where is my 0 point, where is it crossing this axis. So now if I try to draw this polar graph, and because I'm dealing with pi over 4 and 3 pi over 4 and so forth, that's like the x on the graph there. And because my amplitude is only 1, I'm just going to draw one circle around there. So now let's go ahead and start plotting these points. So the first one, when I'm at 0 radians, I'm a distance of 1 unit away. So I'm at 0 units, 0 radians, 1 unit gives me a point there. I get closer to 0 so that at pi over 4, which is this 45-degree line, I'm back at 0. So that gives me a point in this location, right at the origin. Now as I move towards pi over 2, what value do I get to? I get to -1. So remember, if I was graphing the point -1 pi over 2, that's what? It's pi over 2 radians, so over here, but the -1 means I go in the opposite direction. So I come down to here. Then I move back up 3 pi over 4, which is this line here, I'm back to 0. And then as I move to pi, which is out this direction, I'm 1 unit away. So now I have a point here. 5 pi over 4, this one down here is back to 0. And then at 3 pi over 2, I'm at -1 again. So that means when I'm down here, 3 pi over 2, I'm reflected -1 unit away, which is here, and then back to 0. So if I was to now connect all these dots, I go from this point to 0, down to this point, back up to here, back out to this guy, coming around, and you can see what happens here. I get what we call a rose, probably more like a daisy or something like that, but they're called roses, and it's a 4-petal rose, essentially looking in the T formation there. So that's when I have r is equal to cosine of 2 theta. So let me change this up. If you need to catch up or look at it, go ahead and pause. So what we're going to look at now, we want to sketch r is equal to sine of 2 theta. So again, if I draw my sine curve, this 2 means that again it's gotten shortened up so that the period is just pi. So what happens? Well now, again I'm still 1 minus 1. I make a complete cycle in the distance of pi. So if I do that again, It gives me that value. So now again, I'm at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So I'm going to draw the same polar graph. Whoops. And again, because I'm just one unit, my amplitude is 1, I'll just draw the one circle around. So now when I'm at 0 radians, my point is at 0 units out. So I'm actually starting at the origin for this graph. When I get to pi over 4, now I'm 1 unit away. So you can probably already see what has happened to this graph. So when it was cosine, it gave me the T formation. With sine, it rotated 45 degrees. So if I keep going around and plotting these points, I'm going to end up with the petals at its farthest point along my pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So this one would actually give me a graph. Again, a 4-leafed rose, as it's called. It's now set up along the 45-degree angles. So that's my sketch of r is equal to 2 sine of theta. So in general, so I'm going to go erase this, pause if you needed to. So for the roses, in general, if we have r is equal to a cosine of n theta, or we could have the equation r is equal to a sine of n theta. When we have the following situation occur. So it's an n-leafed rose if n is odd, and it's a 2n leafed rose if n is even. So that's what we had here. We had r is equal to sine of 2 theta. So our amplitude, the a, just tells us how far out the leaf is going. But because we have this 2 here, that's our value for n. So that means because n is even, we're going to have 2 times 2, or 4 leaves, which is exactly what we ended up with here. So that's it for video 3, the roses. Biggest thing is n leaves if n is odd, 2n leaves if n is even. Come on back for video 4, we'll look at limacons, which will be the last special kind of polar graph we're going to look at.